Chemistry video lessons. How to determine the percent yield of a chemical reaction. The percent yield of a reaction is the amount of reactants that actually form products. As an entry-level chemistry student, you have the belief that each reaction we work with goes to completion and all of the reactants turn into products. This is not true. In reality, a typical chemical reaction only produces about 50 to 60% of the reactants into products. Sometimes they can only get 15 to 30%. This has to do with concepts of kinetics, which is the speed of the reaction and the amount of energy that goes on, spontaneity, which determines on the free energy and how much energy it's going to take, and other characteristics that nature throws in there, which you would study in an upper level chemistry course, but those are beyond the scope of this course. All you need to do for this class is to understand that not all reactants will form products, and the percent yield is a rating of how much actually does form products. Now here's a typical problem that you might see on the mandatory pass exam. Okay, it says in a chemical reaction between excess lithium nitrate and 48.6 grams of magnesium metal, 62.19 grams of magnesium nitrate was produced. What is the percent yield of this reaction? Well, the first thing we need to know is that the percent yield, the formula for that, so we would say percent yield equals the actual amount made divided by the theoretical, or if it all went to completion. And we know that that's not true, but we have to base everything we do off of this theoretical yield. So I'm usually always going to have to create a balanced chemical equation and determine how much would be made if all of it went to completion. So in this reaction, as always, the first thing I must do is create a balanced chemical equation. So I would take lithium and nitrate. It's a +1 and a -1, so they're balanced out. We're going to add pure magnesium metal, and it's a single replacement reaction, so I'm going to create magnesium, which has a 2+ charge now, nitrate, and there'd have to be 2 of those, plus lithium metal. Now to balance this, I would take a look and balance my metals first. Okay, here's a metal. I've got 1 lithium, and I got 1 lithium over here. So here's a metal, I got 1 magnesium, I got 1 magnesium here. So I'm okay so far. Now I go to my nonmetals. My nonmetals here are going to be my nitrate, and I have 2 of them. But over here I see I only have 1 of them. So I now have to put a big 2 in front of my lithium nitrate. So now my nitrates are balanced, 2 nitrates on this side, 2 nitrates on this side, but now I have 2 lithiums and I only have 1. So I have to come back over here and put a big 2 in front of this lithium. Now I've got 2 lithiums, 2 lithiums, 2 nitrates, 2 nitrates, 1 magnesium, 1 magnesium. So now that I have my balanced chemical equation, we can start to solve this problem. Okay? So once again, we take our balanced chemical equation up here. We have lithium nitrate plus magnesium creates magnesium nitrate plus lithium metal. We ended up with 2 here and 2 here. Okay? Now, according to the problem, we had 48.6 grams. So I take 48.6 grams of magnesium. And I know that magnesium, looking at the periodic table, is going to weigh 24.3 grams. So as always, I put my units that are on this side, put them down below here, grams of magnesium. Immediately put on top where I want to go, moles of magnesium. Okay, 1 mole, 24.3 grams. Put my other fence post in here. Now I've gone from grams of magnesium to moles of magnesium. And they gave me, as we talked about, 48.6 grams of magnesium. But the question was, how much of my magnesium nitrate was made? So if I look at this, I put what I want on top, moles, magnesium nitrate. I put underneath moles of magnesium. Whatever was in this box, remember, goes down into this box. If I look at this, this is a 1-to-1 ratio. So right off the bat, it doesn't make any difference. It's 1-to-1. How many moles of magnesium I make, I'm going to make that many moles of magnesium nitrate. Okay? I look and I add all of this up over here so I can figure out exactly how much is in a mole. And I can find out, okay, that in 1 mole of magnesium nitrate weighs 100.3. Let me check my calculator here. That would be 100.3 grams. Okay? So I got moles of magnesium nitrate here. Moles of magnesium nitrate here is canceled out. This is canceled out. These are canceled out. If I do my math, I take 48.6 times 1 is 48.6. Divided by 24.3 gives me 2 moles. 2 moles times 1 is 1, or is 2. Divided by 1 is 2 times 100.3. So I'm going to create 200.6 grams of magnesium nitrate. Okay? Now, as we talked about, percent yield is actual over theoretical. This that we just created here, by saying everything went to completion, is the theoretical. Okay? This is the theoretical. And this is what we usually always have to calculate out. So if we remember, our formula is percent yield equals actual divided by my theoretical. And I'm just going to put theory here, okay? So, according to our chemical equation, if we remember back at the start of this problem, we had 48.6 grams of magnesium. We should have been able to create 200.6 grams. But according to our problem, if you remember back and we look at it, it said that the actual was 62.19 grams. That's what was given to us in the problem. The theoretical goes down here, 200.6 grams. So when I divide those two, I come up with a number of 0.3, basically 0.31, 0.33, okay? So I come up with a number of 0.31, and we'll say some change type deal, but that's okay. Now, you could either leave the answer like this, or you could multiply it by 100, and it would equal 31%. And that would be the percent yield of this reaction. Now, there are other times they will give you the percent yield, and you have to be able to calculate what actually was created. So in this question, in a reaction between 85.73 grams of copper 2 nitrate and a solid iron bar, iron 3 nitrate was created. How many grams of iron 3 nitrate were created if the percent yield was only 72.3%? So now I'm going to take, and remember, percent yield equals actual over theoretical. So if I take that, what I have now is I have 72.3%, and if we divide that by 100, you would end up with 0.723, just make sure you remember that, equals actual, I don't know what it is. And I got to come up with this number down here for my theoretical. And that's where we will take and come up with our balanced chemical equation and take our 85.73 grams up here and figure out what the theoretical is. Then we will plug that number in here and we'll figure out what the actual is. So let's create our balanced chemical equation. We've got copper, 2 nitrate, and we're going to add it to pure iron, and we're going to create iron 3 nitrate and pure copper metal. So once again, we go through and we balance our metals first, okay? Here's a metal copper 1, here's a metal copper 1, here's a metal iron 1, here's a metal iron 1, we're okay. Now we go to our non-metals, which is nitrate in this case. On this side I have 2, and on this side I have 3. What I usually like to do is just take, if that's the case and I got 2 odd numbers like a 2 and a 3, I will just take the 3 and put it up here, and I'll take the 2 and I'll put it in front of here, and I'll see if that doesn't help me out balancing things out. So now I've got 3 coppers here, and I only have 1 here. I got to put a 3 over here. Okay? 3 coppers, 6 nitrates. Okay? 3 coppers, 2 times 3 is 6 nitrates. 2 irons, got to put a 2 up in front of here. So here's my balanced chemical equation. The next thing I know I got to do is I got to figure out, before I even get into my calculations, what is the molar mass of iron 3 nitrate. So if we add up 1 iron, 3 nitrogens, and 9 oxygens, that's going to come up to, let me see what my calculator shows me to do here. Iron 3 nitrate is going to weigh 241.85 grams. So this one here weighs 241.85 grams per mole. And I'm going to need that. Okay? Now I've been given 85.73 grams of copper 2 nitrate, so I'm going to need to figure out what is the molar mass of that. And by adding up 1 copper, 2 nitrogens, and 6 oxygens, I come up with 171 point, look at my calculator here, 5 grams per mole. So now I can start to do my problem. First thing we're going to do before we turn the page, because I'm running out of room here, is let's figure out how many moles of copper 2 nitrate we have. So we start with 85.73 grams of copper 2 nitrate. Draw my fence line, first pole. First thing I'm going to do is put my grams of copper 2 nitrate over here underneath. Okay, and I want to go to moles of copper 2 nitrate, so I put it on top, and I know that 1 mole, and we already figured out, was 171.5 grams. So if that's the case, and I take 85.73 times 1, okay, and then divide that, I'm going to get 0.5 moles, okay? So that's how much copper 2 nitrate that we can get, okay, from this. So let's go to the next page, and we're just going to take, over on the next page, we're just going to start with this right here, and then our balanced chemical equation. We've got our balanced chemical equation up here at the top. So we'll put our copper 2 nitrate plus iron metal, and this was 3, and this was 2, and then we go over here, and if I remember right, we had 2 iron 3 nitrates, and we had 3 coppers. Okay, so now that we get down here, we know that we had 0.5 moles of our copper 2 nitrate, And we need to figure out how many moles and then how many grams of our iron 3 nitrate over here. So once again, I get here and I say, okay, this is 3 copper 2 nitrate and 2 iron 3 nitrates. Okay? So right off the bat, I take 0.5 times 2 is 1. 1 divided by 3 is 0.33 moles. Okay? Of my iron 3 nitrate. So then if I take my 0.33 moles of my iron 3 nitrate and I multiply that, if you remember back on the other page, you can stop and go back and take a look. We figured it out that this was 241.85 grams per mole. So 0.33 times 241.85 is going to give me 79.81 grams. Now that is my theoretical. Okay, that's my theoretical amount. So then once again, when we take a look at our equation here, it said that we had a 72.3% yield. So 72.3% yield is the same thing as writing as 0.723. Okay, so I'm going to put that in my equation here. 0.723 equals the unknown that we're trying to figure out over 79.81 grams. So we do the math, multiply each side by 79.81, those cancel, multiply this side by 79.81, and what I'm going to end up with here is that I will have created the actual amount. I will create 57.7 grams of my iron 3 nitrate. Now that's how we can go through and step through each different type of problem you could get for percent yield and be able to come up with the answer of what we're looking for here. Please go back and review this as many times as possible. There was a lot of stuff in here, but you need to just go over and over and over it again. And if you think of any questions, write them down and bring them into class, because I'm sure there are other students who are also wondering the same thing but are afraid to ask. Remember that chemists try, but never, ever, ever give up. You can do it. Stay gritty out there.